basic functions of pulmonary system, right? Functions of pulmonary circulation. One function everyone knows, that is gas exchange. Everyone knows that blood which is coming from here, it is rich in carbon dioxide and poor in oxygen in pulmonary artery, and of course you know that carbon dioxide will leave to the alveoli and oxygen will be taken up. That is gas exchange. But there are some other functions also of the pulmonary circulation. One is gas exchange, everyone knows, there's no fun in telling it. What is the other function? Anyone, what is the other function of pulmonary system? Pulmonary circulation. Anyone? Pulmonary circulation. One more function is that the total amount of blood which is held over here, and it acts as a reservoir of blood, right? Total amount in the total circulatory system is how much? 5 liter approximately. Is that right? And out of 5 liter, about 500 ml is maintained in pulmonary circulation. Is that right? About 500 ml blood is present in pulmonary circulation. Out of this 500 ml, 70 ml is present in pulmonary capillaries. 70 ml is present in pulmonary capillaries. Now, actually, if due to some reason, right, for example, there's hemorrhage and bleeding is going on from systemic side, a small amount of blood can shift from pulmonary side to the systemic side. So one of the function of pulmonary circulation is, it is reservoir for blood also. Okay, 2 functions. Third function, very important, third function is very important function of pulmonary circulation. Anyone? Yes, a very important function. I will give you a hint and then you will really tell me. Actually, pulmonary circulation is converting one substance into active form, and that substance produces vasoconstriction. Please tell me angiotensin 1 converted into angiotensin 2, right? So in pulmonary circulation, all of you must be knowing, in the lungs there is an enzyme called angiotensin converting enzyme. In the lungs there is an enzyme called angiotensin converting enzyme, which can convert a substance called angiotensin 1 into angiotensin 2. In the lungs, there is an enzyme, angiotensin converting enzyme, which can convert angiotensin 1 into angiotensin 2. In the lungs, this enzyme, angiotensin converting enzyme, is present exactly where? Very good. That is present at the pulmonary capillary bed. Where in the pulmonary capillary bed? Yes, please. Excellent. On the endothelial cells. These are your endothelial cells, and on the surface of endothelial cells, here are the enzymes which are called angiotensin converting enzymes, and these enzymes convert angiotensin 1 into angiotensin 2. And you must be knowing angiotensin 2 can go to systemic circulation. It's a strong vasoconstrictor, plus it has many other functions, right? Now, so this is one more metabolic function of the, what is this? Metabolic function of pulmonary circulation, that it can convert angiotensin 1 into, yes, angiotensin 2. There are some other metabolic functions of pulmonary circulation also. Pulmonary capillary beds. Another metabolic function is that there is a substance called bradykinin. Have you heard of bradykinin? It's vasoconstrictor, vasodilator. Yes, vasodilator, right? This enzyme, angiotensin converting enzyme, not only convert angiotensin 1 into angiotensin 2, but the same enzyme can also break down the bradykinin. So this enzyme can also work as bradykinase. So this is one more metabolic function of pulmonary circulation. Then pulmonary circulation also work as a filter. Yes, it filters what? Pulmonary circulation. Is some oil filter or what filter? Pulmonary circulation, yes. I'm saying it has some filtration function. Is it air filter or oil filter or what kind of filter? Listen, sometimes in systemic circulation there are thrombi, right? Clots are formed, and these clots or thrombi become mobile in circulatory system and they reach to pulmonary system. Now I will just draw more accurately on this side. This is your right heart. Now this pulmonary vessels, they divide into, of course, pulmonary artery into pulmonary capillaries and eventually pulmonary veins and then to the, yes, left heart. Now what really happens, because blood flow on the systemic vein, venous side is slow, so sometimes thrombi are formed or sometimes there are some emboli. Emboli may be made of fat. For example, someone get injury or multiple fractures and from the bone marrow some fat globules may enter into circulation, right? Or embolus may be of some small clot, right? Or sometimes air bubbles are introduced in circulation by mistake. Now these are all emboli. When they are passing through pulmonary circulation, right, pulmonary artery progressively break down into smaller vessels, and here these emboli are filtered out. Is that right? And most of them, if air bubbles are there, they will be absorbed. Of course, they should not be very large. Or if there is, let's suppose, thrombi, then if there are smaller thrombi, right, which get stuck over here, thromboembolism, smaller, not larger one, then pulmonary endothelial cells can produce fibrinolytic substance and dissolve them. But of course, if they are very large thromboembolism, then there will be damage to the lungs, right? In this way, it can filter some thrombi or emboli, right? Advantage is that these emboli will not go to the systemic circulation. They will be stuck over here and sometimes eliminated. And if they are not going to systemic circulation, it means we have protected the cerebral circulation or renal circulation or coronary circulation or some other important systemic circulatory system from the thromboembolic phenomenon. Am I clear? So how many functions are there? Gas exchange, everyone knows. No need to remember that. Really what you have to remember, number one, it acts as a blood reservoir. Number two, it has some metabolic function. If you cannot remember all metabolic function, just remember one, that there are enzymes here on endothelial cells which can convert angiotensin 1 into angiotensin 2, and then it acts as a filtration bed also, that small emboli which are coming from the systemic veins and they're pumped by the right heart into pulmonary circulatory system, they are filtered out. And of course, there's a problem also here. Sometimes if there is unfortunately cancer there, and if cancer cells go, of course lung will filter out many cancer cell masses and lungs will become a very favorite site for metastasis. That is an unfortunate price which your lungs pay, because they love to filter the things out of systemic venous blood coming to them. Is that right? So sometimes if someone has cancer and cancer group of cancer cells jump into circulation, they may be filtered out in the lungs and lungs may become the site of secondary metastasis. Any question up to this? Is there any question? There's no question? Okay.